Good morning, ladies and gentlemen. Happy Wednesday. Today is April 1st, 2020. Welcome to another episode of Mr. Vasquez's online math lessons. Today, we're going to talk about something called inscribed angles. Let's see what those are. Notice and wonder. You guys know how much I, Mr. Vasquez, love a good notice and wonder. Unfortunately, we can't really do this online, but this picture is a perfect example of an inscribed angle. An inscribed angle is an angle written in a circle. The key thing you're looking for is that the vertex of the angle is on the circle. We can see here that arc BC is highlighted. We would call arc BC the associated arc for the inscribed angle. So the question we're going to address, how are these two things related? So here you can see a circle with the central angle and the inscribed angle drawn in with the same associated arc. Already we can tell that the inscribed angle is half the measure of the central angle. Now that could be a coincidence, kind of like my voice is randomly higher today, but watch as the angle moves around the circle. No matter where the angle is placed, as long as it has the same associated arc, the measure stays the same. We can try the same thing with a different size arc, and the relationship still holds true. So this brings us to the inscribed angle theorem. The measure of the inscribed angle is half the measure of the central angle that defines the same arc. Now we didn't exactly prove that this is true, but based on our observations, we have a pretty good idea that it is. For now, we're just going to call this an assertion. Now let's apply the theorem to prove that two triangles are similar. So in this picture, you can see that we are given the measures of arcs CE and DB, but nothing about the triangles. I know, not super helpful, Mr. Vasquez. But this is actually enough information to find all the angles in the triangle. You just need to recognize that most of the angles in the triangle are inscribed angles to the circle. Take a look at angle CDE. Using the inscribed angle theorem, we can determine that the angle CDE must be 50 degrees because it is half of arc CE. Now take a look at angle CBE. This inscribed angle defines the same arc, and therefore it must be 50 degrees as well. So now we know those two angles must be congruent. Using that same idea, we can show that these triangles have other angles in common as well. The measure of angle DCB must be 70, and the measure of angle BED must also be 70. So now we have shown that these triangles have at least two angles in common, which is enough to prove that these triangles are similar by the angle-angle similarity theorem. We could have used the pair of vertical angles in the middle, but I wanted to explain to you the inscribed angle theorem. So this worked for these arc measures, but would we still be able to answer this question if we didn't have those numbers? Yes. If the inscribed angles have the same associated arc, then they must be congruent to each other. This works even when we don't have the exact measures. So if you have a teacher that doesn't give you numbers like I, Mr. Vasquez, then you can still prove that you have congruent angles.
So that's all we have for today. I hope you enjoyed this video. I want to give a big special thanks to my wife for helping me make this video.
She's the best!
Until next time, stay safe out there. See you. So you're just going to do everything up to click, then we're going to move the camera down.
Okay.
Now remember, this is coming in right from the intro. So it's
Do that again?
My goods.
Hello.
Oh.
Good morning, ladies and gentlemen. Happy Wednesday. Today is April 1st, 2020. I don't know.
Just let it roll.
Oh, it's still going. Oh, my script. Angle. Now that could be a coincidence, kind of like insert joke here. What was I gonna say? Yes, if the inscribed angle is so hard to say, by this angle similarity theorem, blah 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 blah,
You said
is enough to prove that these triangles are congruent by the angle similarity theorem.
I'm sorry. I need to actually correct that too.
I'm reading off the script.
Can you change the word congruent to similar? Because the triangles are not congruent, they're similar. That's
The
a
math teacher is giving me wrong information.
That's a math fail.
Math fail. So now we have shown these triangles.
I'm sorry. So that's all we have for today, folks. What do I have to say?
You have to thank me.
I want to give a very special thanks to my wife for being the coolest person ever.
She